Hello, once again. um, this is Al, and this is moving back to continuing on with the C++ tutorial, and where we are currently. And if you haven't visited this my site before, you can always get to the first video in the series by clicking the link in the video description, which had been broken but hopefully is now fixed, and that will take you to the beginning of this series. Now, in order to help outline what the issue is that I described, and maybe it wasn't clear what the issue was, the final issue to do with our TsStray interface was to somehow combine the functionality that we've already combined and used in order to implement this program, the QuickBliss program, and the TsTray, which had a bug, by the way. TsTray, this didn't work with the last release, and this is no real need for me to go into the details, but I guess I can quickly just explain that although it was working with other windows, the command processor is special in that the enumeration of top-level windows for a command prompt, for something that's using the command prompt, fails. Even it says it succeeds, but it fails. Nothing gets called back on, and so my assumption that the list of the list of windows that we had got hidden, was false in that particular case, and I fixed that. And maybe I'll explain more about that later. But let me just outline the two types of, one of the types of proposals for solution of combining what we already have so that we could use the same functionality in this here, which is not derived from the window class, but instead derives from the dialog class, was something like this. Well, this is the problem. The problem is, here we got our TS window, from which we derived something called TsSystrayWindow. And then the two programs could use this common interface, and that's good. We don't have to duplicate the code in these two projects. And this thing just hides some of the Windows API stuff from us. Now, sysman will ultimately derive from TsDialog, which is the analog of TsWindow, and it also has the effect of hiding some of the Windows API from us, and our dialog classes derive from that. And somehow we'd like to be able to reuse the same functionality in here. And how do we do it? One of the proposals I mentioned was something that looks like this. So here's TsWindow, and here's that. What I've done is taken away the TsStray managing part from TsWindow, and assume, okay, let's suppose we make up a new thing called a TsStray manager, and what we can do is just derive from both. Alright? So our classes would have two base classes. Similarly, sysman would do the same thing. So that's what I call side derivation. This TsTray, derives from both this and this. So it is a TS window, and it is also one of these managers. Similarly for the other two. Now I tried that approach, and it was an abysmal failure. I didn't really think that it would work anyway. A lot of the reason why it failed was just my own mistakes, but I think it's lucky that I didn't find out what I was doing wrong. I couldn't get dynamic cast working somehow, and I was always getting null. I would take the this pointer for one of these things and try to dynamic cast it to this, right? And I would get null. Or first I would get non-null, and then I would get null, and the behavior was not consistent. And that was due to my own misunderstanding of the way you're supposed to use dynamic cast in a scenario like this, where can I make a new one of these? No. If you derive from two objects, or two classes, right? Here's your class on the bottom, and if you derive from this and this, those are both base classes, right? Now in memory, we need text, red text, let's say, big red text, A, B, D for derived. In memory, what is this going to look like? Well, depending on the order, it may look like this. Boxes. Well, it's going to look like this, but what may change is the following. It might be A, B, this is always D, or it might be, this is easily B, A, D, oops, D. Depending on which the order in which you derive from these classes. If you say D, public A, public B, then I think you get this: A, then B, then D is an A, B, D. Or if you put B first, then A, then it'll be in this order. All right. Now, both of these things have virtual functions, turns out, in this case. So that means that this thing, text, has a V table, which is usually given the name V, ETR, VF, something like that. A, something like that. So this thing's got a virtual function table. So does this one. VF. I don't think that's the name, but it's something similar. Okay. As well, the derived class has one. Alright. Now, this virtual function table contains one element. This virtual, it turns out, it's just the one callback notification for the, if this is the system tray manager thing, there's only one callback that you have to implement, and only one virtual function besides the destructor on notify from click or mouse move or whatever. This one as well. This class has two elements in its virtual function table. So if you were to view D as an A, that means that as an A, you should only see two elements in the virtual function table. As a B, you should only see one, right? Now there's only one possible way that you could accomplish something like this, right? You have to have each of these, this has a virtual function table, this has a virtual function table, this also has a virtual function table, and this virtual function table cannot be either one of these because they have different numbers of elements. So this has to be yet another brand new virtual function table that contains three elements. So we've got three virtual function table pointers in our class instead of just one. If it's straightforward derivation, there's just one virtual function table involved. Like if B derived from A, right? Those would combine to make a new second virtual function table, which our class would inherit. And B here would have the same virtual function table if it derived from A, right? It would have pick up 2 from A and has one of its own, that's 3, and then we don't have any more, so we would just inherit B's table. Slightly. I mean, we always get our own because of the destructor part, but it would be, the rest of it would look like B. Now that's a very confusing mess, and so I came up with another idea, which is I don't know if it's a standard idea, but it worked. In fact, I implemented it almost right after uploading that video, but because of it's kind of lucky I didn't upload it then, because in the meantime I found the other bug, and it seemed like that video was getting more than the usual number of views for reasons unknown, and why spoil a good thing while it's going on. Now here's my third solution. I don't know if this is a standard way to do it, but pictorially it looks like this. The TsSystray manager, I retain that TsSystrayWindow thing, but and I do invent a manager type class. Okay, maybe I'll give it a different color. That is, I want black. Now I want red. So this here, I don't want red text. So I invent a TsSystray manager type thing, okay, and that's the thing that has that one callback thing, and everything exactly like before, like TsSystrayWindow, the extended part. This is the extension. from from what we already have. And what I do is I want to make make a TsSystrayWindow using this. So just like before, with this and so this means almost no code changes to their derived thing. But this TsSystrayWindow is slightly different. What it does, first, it requires you to override yet again that text. Virtual, on, I forget what it's called, something like that. It takes two numbers and it's initially unimplemented, so you have to, the deriving class has to implement it. Okay, so same as before, but what I did is instead of deriving or anything from this manager, is I put one inside here. Okay, now this keeps things simple for me because I know where everything is and I know how everything points to, where everything points to and whatnot. And so this is just a member of this class. Text. And I call this manager. But it's not exactly one of these things. What it is, it's something that's derived from that. So maybe I should put this at the top and even put a box around it. What I do is I take that and I derive something from it called systman, another class, which implements the interface requested by that. Small line. Is that a box? Oh yeah, okay. And a line, if you can see it. Okay, something like, it's called systman, and it implements the systray manager's thing, so it has a member on systray message. And what is that? What this thing receives as another member, well, besides the implied member, is a pointer to the containing class. I run out of room, but I can fix that. Here. So inside here is a what I call a P container. And that's a member. And that P container, it's supposed to be an R. That P container points to the outer box. How do I indicate that? So that's my manager, and within manager, that's one of its members. Okay, try to imagine. Here's one thing. An M manager, and it contains a pointer to this whole class inside of it, and I'm going to need that. I use that because I have a way in which I can retrieve the pointer to the whole class, and from that I can then get a pointer to the manager, and then use the systman class that it's called back on to invoke this function, right, to the derived class that has to implement this. Now, the derived class down here uses this M manager that's made public. Maybe it could have been protected, but it doesn't matter. So this thing uses the manager thing to call the functions that deal with the icon, that deal with the system tray. So wherever it said add set tip, you would say mmanager.setTip. Okay? And that thing knows how to handle that. But further, this manager thing uses a technique that we haven't covered really, and that I probably should cover before showing you how all this works, called subclassing a window. And what that involves is replacing the window procedure of a window with one of its own, right? And then chaining to the real window procedure for what it doesn't need to deal with. That's called subclassing a window, replacing the window procedure part. So therefore, this derived class no longer needs to check any private message stuff. So there's no private message checking. None of that going on in the derived class, and the reason for that is because the TsSystrayManager thing subclasses the entire window and checks first to see if it is one of its private messages and doesn't pass those messages back down to the regular window thing, and so none of that gets through to this. And all that happens is that this guy has got to override, it's got to implement this function, and that's it. Now that's for TsSystrayWindow, and for the dialog version, it's exactly this. I do exactly the same thing. make a manager thing. The P container part is to a TsDialog type thing, but it makes no difference. The code's exactly the same. Alright, now I guess that should be enough. That's the outline of how it's set up, and it's working for these. You just saw an example of it running. Tray uses it. But what I've got to do is first just show you how subclassing works in a simple case. So we can subclass a window, and I'll try to think of a simple example. Just see how that works, and then I'll show you how that all ties together with what I've got. Okay, so this is just a heads up, and next video will be hopefully short explanation of how to subclass a window, and then the final one in this mini-series, putting it all together to make that little red box, and then making another similar red box for the dialogues, and since the code is exactly the same, and the only thing that changes is the type of container, I can turn that into a template. So therefore there will just be exactly one template class where all of the details are contained, and any code modifications done there would apply throughout the entire system without having to modify more, 20 different projects. One modification will affect everything and fix everything that uses it. Okay, see you then.